Hello everyone, welcome back to part 4 of this lecture on options. So now we're going to talk about the put-call parity. And this put-call parity is going to be very useful if you already know the price of a call to calculate the price of a put, or if you already know the price of a put to calculate the price of a call. And exactly how this is useful will follow more next week when we talk more deeply about how to price options. For now, I wanted to introduce you already to this put-call parity so that we have the tools next week to keep analyzing. So essentially what the put-call parity is it converts call option prices to put option prices. And how does it do that? Well, by noting that, if you have a certain portfolio, that you can insure against downward risk in two very similar ways. So what can you do? Well, you can either buy a certain stock and then buy a put option. So suppose you want to own a stock and have the upside of owning a stock where it starts paying off, but want to protect yourself against the downward risk. So that way what you can do is hold the stock and buy a put option so that you can always sell this stock for the exercise price in the put option contract. This is also called a protective put. You protect your stock, your portfolio from downward risk. And that gives you a payoff like on the left hand side in this diagram here, right? So if we have certain stock which can have a certain value, so 0 to 75 here, then the value of that stock, so the blue dotted line, is simply this 45-degree line. So this is 45 degrees. And if you then have a put on that stock with an exercise price of 45, well, if the stock price is above 45, you can simply sell the stock in the market. So suppose the stock price is 60, then, well, you simply sell it for 60. And if the stock price drops below the exercise price, so for instance it drops to 30, well, you could sell it in the market for 30, but what you'll actually do is sell it in your put option contract, so exercise your put option to sell it for 45. So that means that your payoff for this protective put is simply going to be 45 unless the stock price is higher, and then you have the value of the stock. So can we replicate a payoff structure just like this with a certain call option? And it turns out that yes, we can. So because if we look at the way this payoff is structured, so this payoff is structured where here we have the value of the stock and here we have the option value, then essentially this looks like, well, just this horizontal path and then an increase. So this looks like the payoff to a call option, if you recall. So maybe we can go long on a certain call. So this is long. Maybe we can go long on a call, buy a call option, and then replicate these payoffs. And indeed we can. So what happens if we buy a certain call option with exactly this $45 exercise price? Well, the value of this call is going to be 0 if the stock price is under the exercise price, because then you simply won't exercise the call option. You might as well buy in the market rather than exercising your option and buy for 45. But once the share price increases, then the call option becomes worth something. So at 60, this is going to be worth, well, 15, because then when you exercise the call option, you're buying it in the market for 45, you're selling it in the market, or you're buying it through the call option for 45, you're selling it in the market for 60, so the value of your call option is 15. So this is the value that you get from a certain call option, but then of course you also need this difference right here. So you also need this certain payoff of 45. So how can you obtain that? Well, by buying a certain riskless bond that always gives you exactly 45 in this case. Because if you enter into a contract with a riskless bond that gives you exactly 45 and a call option, well, as long as the stock market price is below the exercise price, that will simply give you 45, so the value of this riskless bond. So in this case, this is 45. And if then the stock price increases, well, you're still getting this 45, but for instance, when the stock price is 60, then you're also getting this 15 from the call. So 15 plus 45, of course, 60. So you get the exact same payoffs from a protective put that you would get from entering into a riskless bond with the same exercise price as the put and a certain call option with that exercise price. So because they have the exact same payoffs at maturity, they must have the exact same prices, at least when they're European options. So these two different ways to construct the same portfolio should have the exact same price. And that is exactly what the put call parity is. The put call parity says, hey, for European options, so European options, you have the stock price plus the put. So this is this protective put. Protective put should be the exact same value as the present value to a riskless bond plus a call option. And that is what put call parity is. So suppose you know the share price, you know the put option price, and you know the present value of a certain riskless bond, you should be able to obtain the call option price. And to show you that, let's do a little Mentimeter exercise. So suppose we want to buy a 1-year call option and 1-year put option on some company deli bar, and the strike price for each is $15. If then the current price per share of deli bar is $14.79 and the risk-free rate is 2.5% compounded continuously, then we have the price of each call option, and then using the put call parity, what should be the price of each put. I'll give you a moment to pause me. And then I get a value of 2.07. So how does this work? So if we simply fill in the numbers, so the stock price here is $14.79 plus P equals, well, 15, but discounted to present value, so discounted by 1 year. So ERT is 0.025 times 1 plus, in this case, the call option price, 2.23. And then filling in those numbers and then solving the equation gets you a put option price of 2.07. Of course, this pricing of a call or a put with put call parity assumes that there is this perfectly comparable put option in the market and that this put option is priced correctly in the market. But then you will of course ask me, but yeah, why, how can we make sure that this put option is priced correctly if the only way to find it is through the put call parity? So is there no other way to price puts and calls besides this? And to that I will say yes, but you'll have to wait 1 more week before we discuss it when we talk about the binomial model and Black-Scholes. So just to conclude today's lecture, options give you a right to either buy an underlying asset or sell an underlying asset. You have European American options, nothing to do with the location, but European options you cannot exercise until the exercise price. American options you can exercise whenever you want. Can be issued in, at, or out of the money. So in the money if the intrinsic value is positive, out of the money if the intrinsic value is negative, so that you do not exercise it. And they're affected by the stock price, strike price, volatility, maturity, interest rate, and dividends in hopefully intuitive ways. And then we talked about the And then finally we talked about the put call parity, which next week will be a very convenient way of converting put option prices to call option prices and vice versa. So we'll learn formulas how to calculate the call option prices, and then hopefully we can infer the put option prices from there. Of course, you can also calculate the put option price from the ground up, but I promise you in advance that it's easier to work with one formula and then use the put call parity to come up with the other. For that, I'll see you next week. Have fun. Bye guys.